Holden Aluminium. We are proven specialists in the forming and fabricating of aluminium extrusions.
What we're going to do now is look at the flow forming process, which Holden Aluminium also offer. This is a component that we were requested to produce from one of our customers, and you can see from the section we're looking at a twin hollow section, and also the complication of having two bends within that section. With flow forming, you manufacture a tool to suit the inside section of the material that you're trying to form, and then a slipper that goes on the outside. But we're looking at in more detail at the tool itself. So this is the area that I'm looking at, is the tool has to be produced to the shape of the section and also to the radius that you're looking to form, taking into consideration the spring back. With this component, because of the fact that it has a double bend, you have the added difficulty of how you grip the part for its second bend. Under normal circumstances, if it was a single bend, you'd fill these two cavities with a plug so you can grip onto the section accurately to stop any section slipping while in forming operation. We're unable to do that because of the section having two bends, and we can't get a plug into here to grip it. So we worked with the machine manufacturer to develop a machine that would be capable of doing this type of product. We worked very closely with the machine manufacturer to have our input into the machine manufacture and style of build to it. One of the major things that we've asked for, because of this two bend, is the fact that the y-axis, which loads the tool into position, can also give us a physical push forward. And with this push forward of the section, we can reduce the grip on the part itself, and hence any damage that we get onto the section. When we put together the design of the machine with the supplier, it was important to have this docking station to enable us to grip the section, and then this docking station itself and unit slides down the machine and loads it into its position that we're looking to form it. More importantly, this unit itself is driven by quite a large power unit to give us 3 tons of push, so that not only is the material being gripped onto the tool itself, but the docking station and this unit here is actually pushing the material forward. So we can control this to the rate at which the part is formed, and this helps prevent any slip on the tooling itself. We'll show you that on the process itself. So as you can see, the part is loaded into the machine. In this case, we have a gripper at the back of the loading station where the part is gripped. The section's now in its correct position, ready for the first bend, and we'll now operate the clamps and slippers. So the clamp comes onto the tool and grips the part onto the tool, and then the tool rotates as the slipper slides forward, flowing the material around the bend and its tooling. Both components of the slipper and the gripper come off, and the rotating head goes back to its position. Because this is a two-bend operation, the section's pushed forward into its position for the second form. section then is pushed off the tool into its unload position, released from its clamping section, and the part's free to be removed.
Holden Aluminium Technologies is accredited to ISO 9001. We've been accredited since September 2001, so we've just done over 10 years. Some of our customers require very simple checks on their components, such as measuring with a plug gauge for hole diameters, or a simple vernier check for an overall length or hole position. Holden Aluminium Technologies also produce a number of dedicated fixtures for some of the components that we manufacture. This is a forming fixture that we've manufactured, which will check machined features. We can load the components on like this. And then check the hole positions of the machine features. We can also use go-no gap gauges to check the overall length. For more complex jobs, Holden Aluminium has also got a large coordinate measuring machine. This particular component is an Aston Martin bumper beam with about 64 holes and slots in various positions that can be checked fully automatically. On each of the holes and slots, the probe is actually checking a plane around each one, and then we'll check the hole or slot diameter. Initially, it takes several points to achieve the correct alignment for the part, and then from there it will best fit the component to the car line and check the remaining features are all within spec. On the computer monitor you can see that the probe is actually moving around the part and checking the features. It's now doing a plane around this hole, and then we'll check the hole diameter.
So we now look at roll forming, which is a process we also use at Holden Aluminium Technology. Fairly straightforward, where you have 3 rolls, all driven. The centre roll being able to come in and out and produce your bend, and then an encoder to give you the direct position of the part as we're forming. All of those are CNC controlled. So what we can do is pick up a drawing supplied by the customer and then put into that the program that we're trying to look. So you can see from this part that we've loaded, we have a multitude of radiuses and a mixture of radius and straights down the part. This is all done by literally just putting in the radiuses that we require, the length or angle that we're trying to form, and then working out the program from there. Okay, the main advantage of roll forming is that the tooling that we're looking at is relatively cheap, and also one set of tooling for a section can do any radius that you're looking to produce. What we'll do now is I'll hand over to Chris and he'll form the part that we're currently running.
Right, the first part we load in to the machine. We position it so all 3 rollers are in contact with the section, and then we can start the process. The first 2 radiuses that we're forming in here, because they're slight radiuses, we can do it in one sweep. But as we come along, this is the second radius, we can do in one hit. Now this next section, this is a straight, so the roller has basically come away from the part to allow it to keep the form, keep the straight. And now on this final bit, because it's such a sharp radius, what we have to do is we have to do it in segments. And in this case, we've done it in 3 segments, and hence the reason why the back and forth motion. So we can gradually put the radius in. Bring the tool away. So once we form the part, what we have to do is just check the profile is correct to the CNC program that we've got in the board here. And we do that just by sliding the part in. As you can see, this one fits fine.